Assalamualaikum warahmatullahi wabarakatuh. Um, let me begin with the solar radiation. So this is another topic in heating and cooling node subject. Alright, so basically for solar radiation is basically refer to the solar radiation that are influenced to the indoor environment. So the increase of temperature in the indoor environment basically is based on the ambient temperature. So basically based on this is the case for the solar radiation that are directly heated to the building or space, right? So this is some of the terminology. So for the solar radiation, for the example, this is the example for the experiment. Let's say this is the X, Y, and Z for the torchlight. So this is our Earth. So basically for the X, there is the distance between X, Y, Z is all same, but somehow the location is like us here in now in the Earth. For the X is referred to the equator, which is Malaysia, Southeast Asia is located here, and now the North Pole and South Pole here. So which point S, Y, and Z is the hottest. So as you can see now, X is the hottest due to direct radiation, which is now here in equator. So Y is the least hottest because the radiation drop over bigger area compared to the X. Thus, it is less intense as compared to the X, which is the direct radiation. So, this is another example of experiment. So we have done this experiment during our primary school. So by using a magnifying glass, and then we can focus the sunlight or the radiation using the magnifying glass. So of course using the magnifying glass, it will become fast hot because the light become more concentrated. Alright, so now basically this is our Earth. There's Arctic Circle, Tropic of Cancer, equator here in Malaysia, and then Tropic of Capricorn, Antarctic Circle here. So basically there is some degree. The equator basically is about 0 degree, and the Cancer, Tropic of Cancer is 23.5 degree to the north, and then the Arctic of Circle is 66.5 degree to the north. But somehow Tropic of Capricorn is 23.5 degree to the south, and then the Arctic of Circle is 66.5 degree to the south, right? So basically this is our plane of orbit. So basically our orbit is rotated here, which is counterclockwise. So this is the line of our Earth is latitude. This is the latitude here, and this is the longitude here. So we will using some of the formula here in solar radiation calculation. So now there is several things that I would like to highlight here. We have T solar, which is what we call solar time, T sol, which is the time with respect to the solar altitude, and then T standard or standard time, which is the refer to the time that are indicated on our watch. So basically this is the view, some of the examples that are view of the Alaska case. For T standard, here is 10 p.m. And midnight also. The sun is just not totally dark like here in Malaysia, but somehow it just going just below the sun, below to the sunset, and then straight away 6 a.m. keep rising until noon and until 6 p.m. in the evening, right? So this is the same case like previously, which is the equator, right? So this is what we are going to calculate here. There is the formula that we will calculate. So just bear in mind now what we are using. The formula is 1 degree of angle is equal to 4 minutes in time. So if we want to get about 1 hour, it is about 15 degree angle. So the formula that we are using here is we want to find the T-sol. Solar time is equal to T standard time. T standard is minus within bracket location L location standard, which is the longitude, and then L standard L for the location. Then we must plus with ET, equation of time. Right, so this is the formula that we are using in solar radiation topic for this week. So this is the formula that you are using to use. Alright, so just bear in mind some of the terminology. For example, this is the horizon, altitude direction. This is the altitude direction for southeast here to the right, and then zenith is the straight sun to the top of people, and then the north here, west here, south here, east here. Alright, so this is the table that we are using to use the table of solar data for 21st day of each month. So don't worry, usually the question will be referred to the date of 21st, because this is all the data that we have from the table of ASHRAE here. So we are using to use the formula of ET here. So now for this topic, this is the ET for here, ET. Alright, so there is also declination of degree A, B, C. So somehow this is we are going to use for the next topic. So also here, this is some of the data that we get from the meteorological department. So some of the state that we have here from Malaysia, Kuching, JB, KL, Penang, Kuala Terengganu, Kota Baru, Ipoh, Kuantan, Melaka, KK, Miri, and Bandar Baru Bangi. So we have basically the dry bulb temperature in degree Fahrenheit and wet bulb temperature in degree Fahrenheit also. So we have here is L location for the place of the location, longitude for the places of the state here, and then this is the latitude. So this is the value that we are going to put in the formula. Alright, so let's begin. So on the right hand side here, from the formula and appendix table, you need to open to the page 12 and 13. I've converted it to the table of appendix here, page 12 and 13. So let's go and begin with the example. So the first question example is determine the solar time corresponding to the local time of 4:30 p.m. on 21st of October in Bandar Baru Bangi. So here is the formula that we are using to use. The T-sol is equal to T standard, time of standard, minus L standard minus L location times 4. 4 is because of the 1 minute is equal to 1 degree is equal to 4 minutes plus ET. So 4 here is constant times 4 here is constant plus ET, equation of time. So we want to find the solar time. We want to find the solar time here. So L standard here in Malaysia is constant for 120 degree east here. So from the formula that we are using here is 2 point here will be constant, which is the L standard, which is the 120 degree east, and then the 4 here, right? So we want to find the T-sol from the map of L location Bandar Baru Bangi here. Just find from the table 4 in page 12, Bandar Baru Bangi here, L location is 101 degree 48 minute of east here, and then the latitude is 2 degree 56 minute north. Alright, so from table, the ET here, equation of time for 21st of October here, ET October here, and then the ET equation of time here is 15.4 here. Alright, so what we got, the formula is T solar minus T standard minus, if you are using the calculator or scientific calculator, don't forget to put a bracket here in your calculation. If not, you will not get the answer, correct answer. Alright, T solar equal to T standard minus 120 degree east allocation times 4 plus plus ET, which is 15.4 here. And then the time standard given is 4:30 p.m., which is 16 hours and 30 minutes, minus 120 degree is minus 101.48 here, times 4 plus 15.4. So you'll get the answer here. Here you have to minus first. So I'll suggest you to do it one by one. Here you minus here first, and then you times 4 here, and then plus 15 here, and then we'll get the here. Alright, so 57.4 is the answer is from here. So that's why I suggest you to do it one by one to make sure you are not confusing with the calculation. So 16 hour equal to 57.4 minutes here. Then you get the answer of 16 hour 30 minutes minus 2 57.4 minutes is equal to 0 hour and 57.4 minutes here. So you get the answer 15 hour and 32.6 minutes. Alright. Next one, the next example, example 2. Determine the solar time corresponding to the local time. To find also the solar time. To the local time is 2:30 p.m. 14:30 p.m. 14:30 on 21st of May in Kota Bharu. Right? So based on the map, please go to the Kota Bharu here. Here is the allocation 102 degree 50 minutes east. Here. Alright, we want to find next one is ET, equation of time to the 21st of May here. ET here is 3.1. Oh, this is ET should be is 3.1 here in May. This is my mistake to put 3.3. So let's go. Using your own calculation, please make sure you get the correct answer, which is the 3.1 degree. So, but somehow we try to use this calculation. Please use 120 degree east allocation. 120 degree east minus 102.15 degree east times 4 plus this one is should be 3.1. Alright, 1530 here you're using and minus, do it one by one. Alright, so try, you will get a different answer from here because the ET is different, 3.1. Right, so next one, the example 3. But somehow now you are using still to find the solar time corresponding to local time of 11:30 a.m. Alright, the case of this is on the April, ET is 1.1 here, and then the location is in Ipoh. So the 101 degree 7 minute is here. So just put the answer here, the value of allocation and the value of ET, and please try and do you get the answer of 10 hour 16 minutes here. Alright, the next example is to find the solar time corresponding to the local time of 10:30 a.m. on 21st of June in Kota Kinabalu. So the allocation in Kota Kinabalu is here, 116 degree and 11 minute east. The ET, equation of time for the month of June, 21st of June is minus 1.4 here.